Welcome back. We'll be discussing a specific problem and its solution related to vertical curves in civil engineering. We'll be using the following steps to solve this problem. 1. Calculate the distance from the point of vertical curvature to the lowest point on the curve. 2. Determine the elevation at the PVC. 3. Calculate the elevation at the point of vertical intersection. 4. Determine the elevation at the point of vertical tangency. The problem states the initial and final grade of a 600-foot-long vertical curve is minus 3.0% and plus 2.0% respectively. If the elevation of the lowest point on the curve is 92.50, let's solve for the elevation of the PVT in feet. First, our objective is to determine the elevation of the point of vertical tangency on a vertical curve. Vertical curves are essential in civil engineering as they provide smooth transitions between different grades along roadways or railways. Let's start by looking at the given data in our problem statement. We are given the curve length equals 600 feet. The initial grade equals minus 3.0%, final grade equals 2%, and elevation of the lowest point equals 92.50 feet. Step 1 in solving this problem is to calculate the distance from the point of vertical curvature to the lowest point on the curve. We use the formula taken from the NCEES Handbook to determine this distance. Now let's plug in the given values. The initial grade is minus 3.0%, L is 600 feet, and the final grade is 2.0%. Now we can solve for x, which equals 360 feet. In step 2, we calculate the elevation at the PVC using the equation shown here. Before we can calculate for PVC, we need to rewrite the formula. Substituting the values, we find the elevation of PVC equals 97.9 feet. Moving on to step 3, we calculate the elevation at the point of vertical intersection using this formula. Plugging in the values, we see that the elevation of PVI equals 88.9 feet. Finally, in step 4, we determine the elevation at the point of vertical tangency using the formula shown here. Substituting the given values, we find the elevation of PVT equals 94.9 feet. There you have it. The elevation of the PVT is 94.9 feet. Typically, these questions are pretty straightforward on the PE exam. You will be required to quickly identify the vertical curve section in the handbook. You may be tasked with rewriting the equations to solve for a different variable, so make sure you are comfortable with these equations in other forms.